So in another video, we talked about the so-called index of refraction N for various minerals, and we're going to use those examples in this video to talk about something called relief. Relief is essentially a reflection of the shadows that are cast and that allow us to see a mineral or not see it very easily in thin sections. So here I've drawn a thin section. That's what this thing is here. So we have a mineral here shown in green, and it's embedded in some epoxy. And that epoxy, in a typical geologic thin section, that N for the epoxy, EPOXY, will usually be close to or exactly equal to 1.540. It can vary a little bit. Different manufacturers use slightly different recipes for the epoxy, but the index for fraction can be very close to 1.54. Well, if you look back at our other video, values for the index of refraction for something like quartz, so N for quartz, can be very close to 1.54, depending on what direction we're looking at. Let's say it's 1.55, just to take an arbitrary value. So that means as light is propagated through the mineral, from the epoxy through the mineral and back out of the epoxy, it's not going to be bent very much. In fact, if it was 1.54, there won't be any bending at all. So the light comes through, straight through the epoxy and through the quartz as if its quartz grain doesn't exist. And in that case, we would have something that we would say is low relief. The bottom line is that it'll be very difficult to see. The mineral will be almost invisible. And in fact, if the value for quartz and epoxy are exactly the same, then indeed the mineral would be invisible. You would not be able to see its edge because these would be transmitting light in the same way. But let's say we took a look at a different kind of mineral. Let's say we have something like garnet. Now, garnet can have a range of values, so we'll just say we have a value of 1.7. Now, you might ask, if you looked at the prior video, why would something like garnet have more than one value for the index of refraction? It is isotropic. It should only have one value. Well, it can vary depending on its composition. For garnet, we can put in magnesium or iron or calcium into the larger sites, chrome, aluminum, or iron in the 3+ state and some of the smaller sites. So depending on that chemistry, we might get a little bit of variation in the index of refraction. The bottom line, however, is that as light propagates through the garnet crystal, it could be bent rather sharply. And as that is bent, it can cast shadows. You can imagine a light ray coming up, and then it gets bent as it leaves the mineral or as it enters the mineral, and these are going to cast shadows. Those shadows will lead to something that we call high relief, and we'll see some examples of those in a different YouTube video where we can actually look at different mineral grains. The bottom line for us is that these minerals will be easy to see. They will show up very nicely against the background, so they'll be easy to spot in so-called plane polarized light, or PPL. When we talk about plane polarized light, that means is we have light coming up to the base of the microscope. It is polarized, so it vibrates only in one direction, but we're not putting a polarizer lens at the top of the microscope. So it is, when we talk about plane polarized light, or so-called planar polarized light, we mean that it's polarized just to vibrate in one plane. And that's when we look at relief, so-called uncrossed nickels. And again, we'll take a look at some of these examples in some other YouTube videos.